What if I told you that you could hear one of the universe's most catastrophic events from billions of light years away? Black holes colliding. Welcome back, cosmic explorers. Today we're diving into the wild world of gravitational waves. These ripples in spacetime, first detected in 2015, have totally rewritten how we understand the universe. Way back in 1916, Albert Einstein predicted gravitational waves in his general theory of relativity, but figured they'd be way too weak to catch. Picture this: drop a stone in a pool and ripples spread out. Now imagine the pool's the universe, and the stones are massive, speeding things like black holes or neutron stars. So, how do we snag these waves? Say hello to LIGO, the Laser Interferometer, Gravitational Wave Observatory. This bad boy needs insane precision. No pesky earthquakes, ocean tides, or earth traffic allowed. LIGO's got two L-shaped detectors with 4-kilometer-long arms, using lasers to spot distance changes tinier than a proton's width. The lasers ping-pong between mirrors, and when a gravitational wave rolls through, it stretches and squeezes space, throwing the laser path off just a smidge. What's this taught us? On September 14th, 2015, we caught two black holes slamming into each other, proving Einstein was a genius. Then, in 2017, two neutron stars crashed, spitting out gravitational waves and light, possibly cooking up gold and silver in the process. How cool is that? Let's zoom in on that first big win. September 14th, 2015. Two black holes merged 1.3 billion light-years away, and bam, Einstein's theory checked out. Gravitational waves let us peek at stuff light can't touch, like events behind dust clouds or from the universe's baby days. It's kicked off this awesome thing called multi-messenger astronomy, mixing waves, light, and neutrinos for the full cosmic scoop. LIGO's getting souped up for sharper hearing, and new pals like Europe's Virgo, Japan's Kagra, and a future space-based detector called LISA are joining the party. We're even catching primordial gravitational waves, dropping hints about cosmic inflation and mapping the universe's growth spurt. Who knows? With cosmology going nuts, maybe gravitational waves will spot alien megastructures someday. Unless magnetars decide to crash the party, that is. Either way, these waves are the universe whispering its juiciest secrets, and we're finally tuning in. Want more? Check the links in the description. Keep looking up, explorers. If you like this, smash that subscribe button for more cosmic deep dives, and hit the bell so you don't miss our next vid on artificial gravity.